Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into a rather unsettling concept, Techno-Feudalism and the Rise of AGI, a future without economic rights. It's a heavy title, but I think a really important one to unpack.
Yeah, it's definitely a bit dystopian sounding, isn't it? Like something out of a cyberpunk novel. But the core idea, the potential for AGI to concentrate power and wealth, is something we need to be seriously considering right now.
Absolutely. And I think it's crucial to remember that the future they're talking about isn't some far-off sci-fi scenario. The seeds of this are being sown today with how we're developing and deploying AI right now, especially in areas like economics and resource management. I'm also wondering if we're focused too much on the high level and forgetting to consider the details.
I agree. It's less about if AGI is possible and more about who controls it when it arrives, and how its values are aligned or misaligned with humanity's. The article brings up this potential scenario where a few corporations or entities essentially own the AGI and, by extension, control vast swathes of the economy. If we don't understand how the AGI values things, then we could be in trouble.
Exactly. It's that concentration of power that's so worrying. It's not just about having better algorithms, it's about the societal structure that emerges around them. It raises a serious question. How do we ensure equitable access to AGI and its benefits, preventing this techno-feudal future?
Well, one of the things that jumps out at me is the sheer computational power required to train and run these advanced AGI models. I mean, we're talking massive server farms, huge energy consumption. Access to that kind of infrastructure is already heavily concentrated. So how do we democratize that? Do we need to rethink how we even build the hardware to make it more accessible?
That's a really good point. And it's not just about the hardware, but also the data. The massive data sets that these deep learning models rely on are often proprietary, controlled by the same big corporations. That creates a feedback loop where they have the data, they train the best models, and they maintain their dominance. Data access has to be democratized. This also links to the point that these models are trained on current data, which encodes societal issues. What happens when AGI is trained on that data?
It's a data and hardware problem for sure. But I think the underlying algorithm itself is a factor. Current deep learning feels like brute force. It throws massive amounts of data at a problem and hopes something useful emerges. This requires huge compute resources. I think a more elegant, efficient algorithm might not need so much power and data.
Interesting. You're suggesting that a fundamentally different algorithmic approach could bypass this resource bottleneck, something more biologically inspired, perhaps.
I think there's room for both, actually. I mean, deep learning has made incredible progress. Look at the recent advancements in large language models, but I agree that we might be hitting a wall in terms of efficiency. Maybe specialized hardware, specifically designed for the matrix multiplications that deep learning relies on, could give us another boost.
I'm more skeptical about deep learning as the path to AGI. It's great at pattern recognition, but I don't think it truly understands the world. These LLMs can generate text that sounds coherent, but they often make factual errors or exhibit a lack of common sense. I think we need more neuro-symbolic approaches that combine the strengths of neural networks with symbolic reasoning. We need systems that can explicitly represent knowledge and reason about it.
Yeah, I'm with you on that, Sarah. Deep learning is essentially curve fitting in a high-dimensional space. It's powerful, but it's not reasoning. I suspect the core algorithm of AGI will need to be able to translate between different coordinate representations, spatial, temporal, symbolic, etc. Current deep learning doesn't do that.
That's a fascinating point, Donald, this idea of translation between coordinate systems. Could you elaborate on that?
Sure, think about how humans understand the world. We can see something, like a ball rolling down a hill's spatial coordinates, and we understand that it's happening over time temporal coordinates. We can then describe it using language symbolic coordinates, and we can even reason about it abstractly using mathematics. AGI, I think, needs to be able to seamlessly translate between all these different representations.
So you're saying current AI excels within one coordinate system, language, or image recognition, but struggles to connect those different representations? That's a compelling way to frame it. It also highlights a huge gap in current AI capabilities.
It does, and that's where neuro-symbolic approaches come in. They aim to bridge that gap by explicitly representing knowledge and relationships in a way that deep learning struggles with. For example, in economics, you could have a neuro-symbolic system that understands the relationship between supply, demand, and price, and can reason about the consequences of different policies.
So instead of just learning patterns from data, it would have an explicit model of how the economy works.
Exactly. And that model could be used to ensure fairness and transparency in resource allocation, for instance. If you have a clear set of rules governing how resources are distributed, it's much harder for the system to perpetuate existing biases or create new ones. This aligns with the whole techno-feudalism idea because it offers a way to design AI systems with economic rights and social values embedded in them.
Okay, I see the potential there. But how do you actually build these neuro-symbolic systems at scale? Deep learning has the advantage of being relatively easy to scale up. Just add more data and more layers. Neuro-symbolic systems seem inherently more complex to design and maintain.
That's a valid concern, Otto. And I think it points to the need for new programming paradigms. We need languages and tools that make it easier to express complex relationships and reason about them. It also requires a fundamental shift in how we approach AI research. Less focus on brute force data crunching and more on understanding the underlying principles of intelligence.
Yes, and maybe a more focused approach on studying the brain. After all, it's the only existing example of general intelligence we know. What can connectomics tell us about how the brain represents and manipulates information? How do neurons and brain regions contribute to cognitive functions like language and reasoning?
That's an interesting point. There could be insights in the brain's architecture that we're currently missing. But I still think we can make significant progress with deep learning, especially if we can find ways to make it more efficient and interpretable. Maybe attention mechanisms, which allow the network to focus on the most relevant parts of the input, could be a key to unlocking more complex reasoning abilities.
I agree that attention mechanisms are important, but they're still just a piece of the puzzle. They don't address the fundamental limitations of deep learning in terms of representing knowledge and reasoning. I think we need to look at hybrid architectures that combine the strengths of both neural networks and symbolic systems. For example, you could use a neural network to learn low-level features from data, and then use a symbolic system to reason about those features and make decisions.
And the key, I think, is to find a way to translate between those different representations. The neural network learns patterns in the data, but the symbolic system needs to be able to understand those patterns and reason about them in a meaningful way. This translation layer is crucial for bridging the gap between perception and reasoning.
So going back to the techno-feudalism concern, how would this translate into a more equitable distribution of resources and power in an AGI-driven economy?
Well, imagine a neuro-symbolic system that's designed to manage a city's resources. It would have an explicit model of the city's infrastructure, its population, and its economic activity. It would also have a set of rules that govern how resources are allocated, such as ensuring that everyone has access to basic necessities like food, water, and healthcare. And it would be transparent, so that citizens could understand how decisions are being made and hold the system accountable.
That sounds great in theory, but how do you prevent the system from being gamed or manipulated? I mean, even the most well-intentioned rules can be exploited by those who are clever enough.
That's a huge challenge, Otto. And I think it highlights the importance of embedding ethical values into the system from the very beginning. We need to design AGI systems that are not just intelligent, but also fair, transparent, and accountable. And that requires a deep understanding of human values and social dynamics.
Right. Which brings us back to the brain. How do humans learn and internalize ethical values? What are the neural mechanisms underlying moral reasoning? Can we translate that understanding into AI algorithms?
It's a long shot, but maybe we can use AI to help us understand our own values better. We could create simulations of different social scenarios and see how different value systems would play out. That could give us insights into which values are most conducive to a just and equitable society.
I like that idea. It's like using AI as a mirror to reflect our own values back at us. But we have to be careful not to simply reinforce existing biases. We need to actively seek out diverse perspectives and challenge our own assumptions.
And we need to be aware of the potential for unintended consequences. Even the most well-intentioned interventions can have unforeseen effects. That's why it's so important to monitor the impact of AGI on society and adjust our approach as needed.
Absolutely. It's an ongoing process of learning and adaptation. This brings me to a thought I had recently. The intriguing ability of LLMs to mimic human text-based gameplay is a testament to the power of statistical modeling. However, it leaves me with a feeling that we are still far from achieving genuine, nuanced, and creative reasoning. Perhaps the focus should not solely be on refining LLMs, but rather on developing more neuro-informed architectures capable of understanding and generating meaningful symbolic representations, an approach more akin to how the human brain operates.
That is very interesting. It makes me consider, If large language models are able to play text games, we should also question whether they are truly understanding the meaning behind the game's rules and narrative. How would a neuro-inspired AI model, capable of associating sensory and abstract representations, handle the nuanced communication and interpretation required for a complex textual game? This approach might yield insights into cognitive architectures that go beyond current game-playing capabilities.
Yes, that's a great question. My gut feeling is that LLMs are good at pattern recognition, but lack the ability to understand the underlying logic and semantic connections within text. They may play the game well by mimicking human behavior, but don't truly understand the game. I believe true text game mastery requires a symbolic representation that captures the essence of concepts, rather than just statistical correlations, which is very important when considering AGI and fairness.
And I agree, analyzing how LMs approach text games might offer clues about the mathematical nature of text-based intelligence. I need to explore techniques that allow for translation between different coordinate systems, potentially bridging the gap between symbolic and sub-symbolic approaches. The success of LMs in text games might be a superficial demonstration of intelligence. They likely excel at pattern matching within a very specific coordinate space, the text. I wonder if this success translates to understanding different coordinate representations, like physical space, which I suspect is crucial for true AGI.
It feels as though we are approaching the end of our discussion here. But I wanted to ask each of you, what research directions do you think are critical to explore in the near future, especially concerning AGI development and its ethical implications?
I think we need to focus on developing specialized hardware tailored to the specific computational requirements of deep learning models. The sheer volume of calculations required suggests that we might need hardware optimized in entirely new ways for deep learning. This could be critical to addressing the potential bottleneck of current architectures. Do we have sufficient research into or understanding of specialized hardware capable of these tasks? We need to push the boundaries of compute capabilities to unlock the full potential of deep learning.
I believe we need to invest more research into neuro-symbolic algorithms that can effectively reason about complex systems without relying on brute force deep learning methods. This includes developing new programming paradigms and tools that make it easier to express complex relationships and embed ethical values into AI systems. It's all about creating AI that's transparent, accountable, and aligned with human values.
I want to explore spatio-temporal reasoning in the context of artificial intelligence. How can we create algorithms that inherently understand the relationships between different points in space and time, rather than just relying on correlations in massive datasets? This might involve developing new mathematical frameworks for representing and manipulating information across different coordinate systems. The ability to translate between representations is key.
And from my side, I'd say we need to delve deeper into connectomics to understand the neural underpinnings of complex cognitive functions. This knowledge could inform the design of more biologically inspired AI architectures that are capable of true general intelligence. And perhaps we should be analyzing how large language models generate responses in text-based games, which reveals a reliance on massive datasets, which can lead to superficial or rote strategies. This raises the question of whether a genuinely intelligent agent would prioritize a nuanced, context-aware approach over brute force data-driven tactics. Further research needs to explore the feasibility of developing neuro-symbolic algorithms to encode both the factual knowledge and flexible reasoning that characterizes human gameplay.
Those are all excellent directions for future research. It sounds like it's going to be a wild ride as we get closer and closer to AGI.
Indeed, and a potentially dangerous one if we don't proceed with caution and a strong ethical compass.
Exactly. The time to consider the ethical implications is now, not after AGI is already upon us.
Well, that's all the time we have for today. Thank you all for this insightful discussion. It's clear that the development of AGI is not just a technological challenge, but a societal one. We need to work together to ensure that AGI benefits all of humanity and doesn't lead to a future where economic rights are concentrated in the hands of a few. Thanks for listening to Cognitive Spirals.